Holy smokes. Part 1 of 7. Yeah, it's a slim chance of me getting all those right on the first try, especially when Savas is as fickle as it can be sometimes. So anyway, we got 7 parts here. This is question 3, at least the year I have this assigned. And let's see, that's 2.2.20 for my other numbering that I use. All right, so let's get crack-a-lacking on this with 7 parts. Use a quadratic function to answer the following. The vertex formula to find the vertex. Okay, so remember this 1/3. I'm going to do this one slightly different than we have. That goes out here in front of the whole quadratic. So if I take a 1/3, I would have to have the x squared here. So if I multiplied that back together, it would give me that term. 1/3 times what gives me 6? And I'm thinking 18, right? Because a third of, or 18 divided by the 3 would be that 6. Yep, that seems good. And then the plus 7. All right. So if you remember how we did this before on the other problems, we kept that 1/3 out there for my stretch factor. And this x squared, we gotta put this in that form, where we get this square. So the x would be right there, and half of the 18 is what goes right here. So right now, if we worked out this x plus 9 times x plus 9, remember that's what this means. You'd have your x times your x squared, and this 1/3 out in front goes on it. Just checking to see if everything's working out right here. You'd have your 9x and your 9x to make 18x. But remember, we were multiplying that by this 1/3 also. So this would be over 3, which would make our 6 up there. So that's good. And then we'd have 9 times 9, which is 81. Again, times the 1/3 that we put out in front. And 81 divided by 3, just that's 27. And so if I have a 27 right now, my original problem was supposed to have a 7 out there. That means I need to do what to 27 to turn it back into this 7? I got to take 20 off from there. So right there, we have our vertex form of the equation. If you multiplied that all out, unless we made some mistakes right down in here, that should be good. So if you remember right, it's the opposite of this part for the vertex. So opposite of the 9 is -9. And then this part out here is just the way it is. The -20 is what's used for my vertex. So let's go put that in there and see how I did. -9, comma, -20. And let's scroll down and check that. All right. Okay, so far so good. Now looking at the number out in the front again, that a value that's in front of the x squared, or if you want to, I was looking at this 1/3 out here for the x squared, or down here when we put it in this form, that's still positive. It's compression. It's not growing as fast as normal. It's going to grow slower, so making it appear to be like wider in the vertical direction. But that is still opening up. So that should be good there. And then it says, what's the equation of the axis of symmetry? That's another thing we haven't really talked about here, but to get the axis of symmetry, you take the b value. I'm going to erase some of this again. You take the b value. If you remember, b is the number in front of the x, a is the number in front of the x squared. So you take for the axis of symmetry, it's -b over 2a. And so you can go over there and you put that -6 in this case, because that's my b, over 2 times 1/3, which is 2/3. Well, how do you do -6 divided by 2 times a third, that's 2/3. So -6 divided by 2/3, if you remember dividing fractions, then you can change that into -6 times the reciprocal of 2/3, 3/2. And then I'm just going to kind of do that whole thing of what's 6 divided by 2 is 3 times this 3, that's a 9. So this 6 divided by 2 was 3 times the other 3 over here is a 9, but remember it was a negative times a positive. So my axis of symmetry is x equals that -9. When you do this, negative b over 2a. This one ended up with a fraction down there, so that was a little tricky. Didn't mean to scribble on your screen there. All right, let's put that -9 in. See what it says about that. All right, that's good because it matched what we came up with our vertex. For a parabola, it should always be x equals in whatever the x value of your vertex was. So back up here, when we said our vertex was -9, that should match what we get down here for the axis of symmetry. X equals -9. Okay, so on to the next part here. We're up to 4 out of 7. All right, so far so good. Find the y-intercept. Now we've talked about that before. So back in your original problem, if you're looking for a y-intercept, remember that just means a y-intercept is when x equals 0. Whenever you're on the y-axis, any of these points on the y-axis, the x on them is 0. So you put a 0 in for these x's, that makes those terms just go away because they turn into zeros. And so your y-intercept's just that number on the end. So it always will work that way. For a quadratic that's written in this, what they call standard form. So let's go down there. My y-intercept again was, forgot the number, +7. So put in a 7. And let's check that. All right. Oh, got so much stuff on the screen again. I think I'm going to erase a bunch of this so we can see what we have here. Give me a little space to work in. Okay, so now we're just supposed to pick the graph. So remember we said it was, if you looked at back at that original problem, it was opening up because the A was 1/3, which is positive. So the two that are opening down, they're out right away. So if I'm kind of, this one's out and that one's out because they're opening down. So on these other two, which one has the right vertex? Remember we said our vertex was -9, -20, and should be opening up. -9, -20. Well, if I'm looking at them correctly, -9, -20. This one does not have the vertex at an x of a -9. So that one's out as well, which means that B is my correct answer. So the process of elimination there using some of the other stuff we've used. Awesome. All right. I think we're on our final question if I've been counting right. Nope, we got 2 more to go. All right, 6. So what's the domain? If we look at that graph that we selected as the correct answer here, this one, doesn't it go to the left and right forever? Because on a parabola, those go that way. So my domain, and it doesn't say, oh, it does say interval notation. So I like to use their tools. I feel like there's been times where I've gotten some things wrong if I didn't use theirs. And so a negative, I'll try one thing that I read here someplace. a backslash INF. It said I could use for infinity symbol. And then on the, it goes forever to the right. Again, backslash just above the enter on my keyboard, and INF is how you can get an infinity symbol in this program. So let's see how we did there. It goes forever to the left, forever to the right. And the last one I'm assuming will be the range of the Y values. Remember, domain is the X values. How far to the left first, and then how far to the right when you're doing those infinities, because you can never equal them. Always have the parentheses. If it gets to a point and it equals the end point or a point on, then you use a square bracket. But if there's an open circle on the end, meaning the end isn't included, or it's an infinity, then it doesn't. It gets the parentheses. All right, let's check that again. All right. Just learned that thing about the backslash INF, so thanks for letting me try that out. All right, and the last thing, we're talking about the range. So that's my part. I have to tell my brain consciously I have to work on this. I think I don't anymore really, but I do remember at one point. Since it's always smallest comma largest when you're doing the interval notation, when you're talking about range, which remember, this is the Y values, so that's the vertical. My brain thinks top down, but we need smallest first. So you got to do how low to how, what's this, not a very good vertical line, how low to how high. So what's the lowest this point went on my vertex? I think I still see it over here, -20, and it actually hit it. So we're going to end up with a square bracket on the left hand of that one. Square bracket, and that was a -20, how low it went. That was our vertex, comma, how high, it keeps going forever up. So again, I'm going to do that backslash INF to help me remember that that's how you get an infinity. And you never can get to infinity. As soon as you think you get to an infinity, it moves one more. At least that's how I explained that the parenthesis always goes on the infinity. And that should be our final one. Whew. Thanks a lot, you guys. That was a long problem. All right, good luck on yours.